I didn't start right when you reminded me because I hadn't started
Yeah.
OpenCode yet. All right, so can I get a feel for the room here? Should we do one more or two more before I ask you guys to try some?
Maybe one more.
Okay. All right. All right. Let's do one more. So here's something. You'll notice, or maybe you did and maybe you didn't, but now you'll notice because I'm going to point it out to you. Um, if your b in your equation has a pi in it, your period won't have a pi in it. And if your b does not have a pi in it, your period will have a pi in it. So let's go ahead and do one that has a pi in it. All right. So let me erase this. Anybody need me to wait before erasing? Okay. Okay. So let's do y equals how about positive 3 sine of um, x over 3 um, minus 4. Let's get fancy with it here. All right, my midline is y equals negative 4. What's my highest? What's my lowest? What's the highest?
-1.
Good. My highest is -1. My lowest is
-7.
Thank you, Diana. -7. And my period. What's the b in this? What's the number that I'm multiplying x by?
3.
It's not 3. It's not 3 times
2.
x.
2.
Pi times 3. 2 pi times 3.
Okay, so I think you're trying to tell me what's the period. But what's the b? When I have x divided by 3, it's really the same as what times x?
1/3.
Yes. Yes, 1/3 x. So when I see x over 3 in my head, I'm seeing 1/3 x. So my b is 1/3, and my period is 2 pi divided by 1/3, which is the same thing as 2 pi times 3. My period is 6 pi. All right, so all the y values I want to show are negative, so I'm going to make sure I have some space below my x-axis here. And now I'm going to throw down the 3 y values that are important to me. This will be -1, this will be -4, and this will be -7. I'll give you a chance to catch up. I'm sorry about that big light above my head. If I shut off those lights, I won't be able to see. All right, then I'm going to draw some guidelines here. And now I want to draw my shape. I've got a positive number in front of a sine function, so I'm starting on the midline and going up first. And then back to midline, lowest, back to midline. So that's going to be a full cycle. So midline, highest, midline, lowest, back to the midline, try to connect them and be rounded near the high and the low spots, and it'll look pretty good. And then I throw my period at the end of the cycle on the x-axis. And the halfway point will be 3 pi. This is 1.5 pi, or 3 pi over 2. This will be 4.5 pi, or 9 pi over 2. And again, it's important to understand that these graphs go on. So, this keeps going in both directions. But, from what we sketched, anybody could figure out the coordinates of any of these other points, right? This would just be 6 pi plus 1.5 pi. That would be 7.5 pi, right? This point back here, this would be -3/2 pi. It would be on the midline over here at -3 pi, and so forth. All right, so, depending on your teacher, maybe your teacher will expect a little arrow to show that it goes on in both directions, but the important part is that we understand that it keeps going on, and we could figure out where the other cycles of the graph are very easily.
Wow, this was a good one.
What's that?
I said this is good.
Good. Yeah, this is real good for you. It's like okay. So let me give you guys a couple to try on your own. How many? Somebody give me a number. How many minutes per problem do you think you need? Like 5 minutes per problem? Is that about right, or too much, or too little?
Yeah, 5 minutes is good.
Okay. Let me give you 2 to try on your own, and let's see how you do. All right, and I don't think we need to go into breakout rooms for this. Okay, actually, let me go to the next page here. All right, why don't you sketch these 2 problems? Y equals, how about -8 cosine 2 pi over 5x plus 10, and y equals -3 sine 1/2 x plus 3. Let's go 10 minutes on that, okay? And please speak up if you have questions. I'm going to just make sure I have everybody marked down in my attendance properly here. Yes, yes, yes. Yep. Oh, and while everybody's still in the room, just gonna plug it one more time. I'll put a link on the Google Classroom page. Again, I did email that to you guys last week, but just wanted to plug the Friday lectures. Tomorrow, you're going to have a guy named Mr. Souther who's going to preview some calc problems that are called rate in, rate out problems. Give you a little preview of some calculus issues.
So to get b, we do divided by 2 pi.
You'll do 2 pi. Well, the b, you have the b. In the first one, your b is 2 pi over 5, right?
So let's get the period.
Yeah, so you'll do 2 pi divided by 2 pi over 5. So.
Oh. Thank you.
Yeah. Does anybody want to tell what you got for the period on the first one?
5.
5. Good. You should be getting 5 for your period on the first one. If you really think about it, you can see it. That you know this b is 2 pi divided by the period. So if you have 2 pi divided by 5, that means the period is 5. I'm not going to write the answers. I'm just getting ready for when we do. All right. Let me know if this takes away the picture. Are we good?
Yep.
Okay, good. I was just able to finally get rid of all the other stuff that's on my screen, so you don't have to look at everything else. It's been 10 minutes. Would anybody like a couple more before we start going over them?
Yes, please. Well, like, almost done.
2 minutes?
Yeah.
All right.
You can- All right, I'm done.
All right. Anybody else need a minute, or are we good to go?
We're good.
All right. So, just a subtle point here. You'll notice instead of writing midline, I wrote middle. If someone writes midline, please write y equals. But the middle height, this is just notes to ourselves. The middle height is 10. It goes 8 higher and 8 lower. The period is 5. And if you need to, you can get it by doing 2 pi divided by the b, which is really 2 pi times the reciprocal of the b. And something we could have done, I chose not to, but I'm going to show you it's an option now. you can draw your y-axis, and you can draw, you can just put your three heights. You can draw your shape and then put the y values on it if you want to. All right, I got a highest, a middle, and a lowest. My highest is 18, my middle is 10, my lowest is 2, and hey, that means now my y-axis is down here. I meant to use the same color, but we'll just go with it. So now I'm going to draw my shape. It's a negative cosine, so I'm going to start at the lowest, then I'm going to be on the midline, then the highest, then the midline, and then the lowest. Flat coming out of the bottom, flatten a little bit going into the top, flatten going into the bottom. And I'm going to put 5 right here. And if I needed to, this is 1.25, 2.5, and 3.75. In fact, I'm going to put them because it's going to help us answer a question in a minute. Questions on this? All right. Anybody need a minute before I move on? Okay. All right. This one here, the middle height is 3. It's going to go 3 higher and 3 lower. My period is going to be 4 pi because it's 2 pi divided by 1/2, which is the same as 2 pi times 2. So let's do that same technique here. Let's just put 3 values on here. Highest, middle, lowest, 6, 3, 0. Hey, that means this is my x-axis. That's x equals 0. All right, and I'm going to put some, put some guidelines for myself. Oh, I know what I'm doing wrong. I've got the line tool, not the pen. All right, guidelines, and I have a negative sine shape. Any kind of sine starts a cycle on the midline. Then negative sine goes bottom, middle, top, middle. My guidelines are slanted down, so if I'm careful about my guidelines, it makes it easier to sketch the graph. But I wasn't very careful this time. 4 pi is where we end up here. That means this is 2 pi, 1 pi, and 3 pi. What do you guys do? Okay on these?
Yeah.
Okay, good. So part of tonight's homework, I gave you some problems in the book again. Don't follow the instructions. Just take the equations and sketch the graphs the way that we did today. Just for kicks, I'm going to give you a little heads up on some math that we'll worry about next week because you guys took to this pretty well. And Mr. Kaplan's going to say a few things to you guys too about sinusoidal functions, I believe. And but before we do that, let's I'm going to go back to this function right here, and I'm going to erase some of this stuff. All right, let's say I wanted to actually let's tell you what, this is going to be a little more complicated than I want to get into on the first day of this. Let's do this one right here, and then you guys will try one on number 2. Let's say that I wanted to solve this equation. All right, let's say this. This is an equation I'm working with, and for some reason I want to know, I really need to know, when does y equal 4 exactly? All right, so here's the equation I'm trying to solve. 4 equals negative cosine 2 pi over 5x plus 10. Who's got an instinct on what to do first if I'm solving this equation?
Subtract 10 from both sides.
Subtract 10 would be the correct thing to do. So let's subtract 10 on both sides. Negative 6 equals negative 8. Cosine 2 pi over 5x. How about the next thing we're going to do? Anybody?
What exactly are we trying to find for?
We're trying to solve for x.
Can we
Oh, for
divide
x? Okay. So
by
Yachiruza, divide by what?
we divided by negative by plus 8. We add plus 8.
Okay, you were more correct the first time. You're looking at the right number, but don't forget that's not negative 8 plus cosine. It's negative 8 times cosine. So you were correct the first time. We want to divide to get rid of that. So I'm going to divide by negative 8. All right, and I'm going to move this over here because I'm running out of space. So negative 6 over negative 8, I'm going to reduce that to 3/4. 3/4 equals cosine 2 pi over 5x. Who thinks they know what we should do next?
We put the negative, the inverse of
Nice job, Truzy. Yep, inverse cosine. So if the cosine of my angle equals 3/4, that means my angle equals the inverse cosine of 3/4. All right. Last thing I want to do is get rid of the coefficient of x. How about let's use the reciprocal? All right, let's multiply both sides by the reciprocal of 2 pi over 5. So I'm going to have 5 over 2 pi inverse cosine of 3/4 equals x. And what mode do I want to have my calculator in to get an answer? Radians. If I wanted to be in degrees, instead of having 2 pi over 5, I would have had 360 over 5. But I want to be in radians. And some of you are going to understand this without me explaining it to you, but some of you need a reminder here. To put this in the calculator correctly, if you don't put this 2 pi in parentheses, it will think you only want to do 5 divided by 2, and then that you want to multiply by pi. But try it out if you have your calculator handy. 5 divided by parentheses 2 pi, then inverse cosine 3/4, and you should get about 0.575. All All right, and just because this is the first time we're doing this, you always want to use 3 decimal places in AP Calculus. But just for today, I'm going to simplify this to 1 decimal place. Does anybody have it? What is this to the nearest tenth?
0.6.
Good. You should get about 0.6 for x. All right, and the reason I'm simplifying, because I just want to make sure you understand what we're going to do next. So let's, first of all, we have a sketch, right? We could have, I should have mentioned this up front, but I'm trying to solve when y equals 4, right? So on this scale here, if this is 2 and this is 10, halfway is 6, I'm going to say 4 probably is right about here. So I know a reasonable answer is somewhere between 0 and 1.25, but there's another answer somewhere between 3 3/4 and 5. And, you know, we could use like the unit circle. I could think, what's the other quadrant, you know, where cosine can have a positive value, but I don't need to. I can use the symmetry of this graph. All right, this first solution here is 0.6. So can anybody use the symmetry of the graph to tell me what this next solution is going to be? What can I do for you?
I brushed my teeth
Good job.
in the morning.
You already did?
Just to see.
Nice job.
Smiley teeth.
Looks like there's a flashlight in your mouth.
Could they see me?
Yeah.
Thanks. That's nice. I hope they like me.
Thanks for telling me, bud. Anybody?
Is it about 4.4?
Yes, nice job. And there's 2 ways to do this. Probably the most straightforward one is if there's 0.6 is the distance from here to here, then 0.6 is the distance from here to here. And my next solution would be 4.4. All right. I could have also used the distance between 0.6 and 1.25, and that should be the same distance between 3.75 and my 4.4 as well. All right. And just going forward, so next week we'll ask you what's the 3rd time and what's the 4th time. But now you can just use the period, right? 0.6 plus any multiple of 5 is another solution, right? 5.6, 10.6. And 4.4 plus any multiple of 5 is also a solution. 9.4, 14.4. But the calculator gives us the primary answer. We can use the symmetry of the graph to get the secondary answer, and then we can use the period to get all the rest of the solutions to this equation. Just for kicks, why don't you take 5 or 6 minutes, and on the next graph, the one below it, the second that you guys did on your own, why don't you try and solve this? When does you want to try? You want a tricky one or a straightforward one?
Tricky one.
All right, I heard tricky. So let's do this. Tell me, when does this have a value of 4? And the reason it's going to be tricky is it's going to give you a negative value. But see if you can use the symmetry of the graph and or the period to figure out when does this have a value of 4. Let me give you a few minutes. It's also tricky because you got a pi in there too. But see if you can tell me, what's this value and what's this value? Draw that on there to help you out. But and if you've got an answer, let me know you're done in the chat. Then when we're done, I'll call on you, and if you get the correct answer, I'll give you some extra credit. 2 answers.
So do we just give you like one negative answer and one positive answer?
Well, so what I'd like you to do, Mark, is see if you can use the negative answer that you get. See if you can give me this answer and this answer.
All right.
Okay.
Thank you.
nice question, Mr. Sheehan, by the way.
Thank you, Mr. Tapia. We're just kind of getting ahead of ourselves here. But next week, guys, we'll say like this represents your height on a Ferris wheel. When are you exactly 4 meters above the ground and stuff like that. Or this represents a population of animals. When is the animal population going to be 4,000? All right. Sounded like Mark was just about done. Is anybody else done? Oh, I see. Okay, I got another person just told me in the chat they're done. All right. Hey, An, what did you get for this answer right here?
Do I say in pi or in decimal?
Well, how would you do it? Give me both if you can.
Well, I just got the decimal. I
Okay.
got 6.983.
Okay. Sounds like that might be a little high, but and what's this one over here?
11.866.
Okay. So let's run through this math real quickly together, and I'm gonna go quick because we'll spend a little more time on this next week. But the first thing I do is subtract 3 from both sides. That gives me 1 equals -3 sine of 1/2 x. Right. Then I'm going to divide both sides by. Oh, you know what? You're correct. I can see what I did wrong. Yeah, you are correct. I was doing the answer real fast. Nice job. So I'm going to divide both. What's that?
What are the answers? I couldn't hear.
What did you say on for your decimal answer?
6.983 and 11.866.
Okay, 11 point.
And the other one is -0.7.
Yeah, okay. So, yeah, let's keep going here. So I divide both sides by -3, which gives me -1/3 equals sine of 1/2 x, or x over 2, inverse sine of -1/3 equals 1/2 x. Multiply both sides by 2. 2 times the inverse sine of -1/3 equals x. All right, so when I do 2 inverse sine of -1/3, I get negative, just to oversimplify, it would be -0.7, but let's call it negative 0.680. And again, you don't even want to round it off to 3 decimal places if you're doing this in a formal setting. You want to just keep that answer stored in your calculator. But then now I look at the symmetry of my graph. So the distance, and please let me know if I'm going too fast. The distance from here to here is 0.680. So that means the distance from this point where I'm on the midline and this point should also be 0.680. All right. So because this point is on the midline, this is just to the left of it. This point is on the midline. This is just to the right of it. So to get this answer, I would do 2 pi plus my answer, and actually 2 pi minus my answer because it's negative, right? So 2 pi minus the inverse sine of -1/3, and there I'm getting 6.623. Even if you do 2 pi plus 0.680, Oh, interesting, interesting.
I got 6.963.
Yeah, 6.963. Um, oh, I know what I did wrong. Yeah. 2 pi minus 2 inverse sine of negative 1/3. Yeah, 6.693. So looks like you were on the right track there on. And then, I want to do 4 pi minus 0.680 because now this distance is also 0.680. And so, yeah, 11.887. All right, first of all, did I lose anybody? I started going a little fast, fumbling over my own little fingers here. Did I go too fast for anybody? Would anybody like me to back up and over any part of this problem?
I just want to know if we'll be told the points that we need to find, or is it? I'm confused on why is it these specific points we're finding.
Yeah, it's a good point, Mata. So in general, it's an important question. Yes, I would have to be clear about what I'm asking you for, more clear than I was today. But here's something that's important to understand. No matter what version of this anybody gives you, this answer and this answer are they're kind of the same answer because one is 4 pi away from the other one. They're one full cycle away. Like this point here that I'm highlighting is when I'm at a height of 4 on the way down. This second point here, I'm at a height of 4 on the way down. So if you found this one, you can just add 4 pi and you've got this one. Somehow there's another set of answers where I'm times when I'm at a height of 4 on the way up. And you do have to use symmetry of either your graph or go back to the unit circle to find those other sets of answers. So there's this answer, but somewhere over here I'd be at a height of 4 on the way up also. And somewhere over here I'd be at a height of 4 on the way up. Did that answer your question a little bit?
Yes, thank you.
Okay, good. All right, let's take a break from what I'm talking about. Mr. Kaplan has some stuff he'd like to share with you guys about sinusoidal functions. And let's give him whatever time he wants, and then whatever time we have left, we'll hit up a little bit more exponential functions.
Okay, I'm going to try to share my screen. I hope that
Beautiful.
works.
Yeah, let me stop share here.
Wait a minute. All right, let me see if I can do this. All right, do you see that?
Yes.
Okay, this is the front panel of an electronic device called a function generator. And the word function is the same way we use it in math. This generates functions where voltage changes in a certain way. And if you look up in the right-hand corner, there are choices: square wave, sine wave, and triangular wave. So if we choose sine wave, we'll get a sine wave. Now, I don't know if you can see my cursor, but the range area and this knob, the big knob on the left, determine the frequency, which is 1 over the period. So that's related to B. The offset knob is related to the D parameter that you just studied, and the amplitude is related to the A. So this device will create a voltage that corresponds to the functions that you've just been studying. And let's see if I can scroll down. The function generator is connected to an oscilloscope, which lets you see the electrical signal. There's the sine wave. And this one also makes an extra pulse that occurs at the bottom of each sine wave. So for the longest time, I didn't realize that when they use the word function, for a function generator in electronics, they're talking about the same kind of function in math. So just to go over this one more time, here you can choose the shape, and for what you've been studying would be a sine wave. These knobs adjust the frequency, which is 1 over the period, which is related to B. The DC offset is the, I'm sorry, this is related to B, B as in Baker. The DC offset adjusts the D value that you've been studying, and the amplitude adjusts the A value. Now, if I'm really lucky, there's one other thing I'd like to show you. Okay, can you see this? This is a different picture. Here, somewhere, down here, is, I hope. But this is an oscilloscope trace on a slightly more modern oscilloscope. Here's a sine wave that was generated electrically. The x-axis is actually a 1, not at the dotted line. And you'll notice there's 2 divisions at the top. That's the period.
Wait, did you change the picture?
Yeah, there's still
Yes,
we're still
yes. Did you see that? You see a new picture?
no, we're still
I
seeing
don't.
the same picture. We see on the left-hand side there's a second thumbnail that it looks like you can click on. I'm not sure if you were
wait
trying to
a
go to your
How
second
about,
page.
okay, all right, wait, okay, hang on. How about now? Do you see a different picture?
No.
No? All right, let me try one more thing, and then I'll just not do this. Let me,
You were able to
Where is
scroll
it?
down earlier.
Yeah, if you scroll down.
okay. You see it now?
No, it's not scrolling for
No.
us.
No, all right. Let me try one more time, and then if not, we'll just skip that part. Let me get rid of this one. And screen sharing has stopped. Okay, wait, I'll go back to screen sharing. I don't, let's see. Okay, how about now?
Can you share your screen again?
Oh, okay. Wait a minute. All right. How about now?
Yes.
There we go.
Okay, so this is another oscilloscope pattern from a slightly more modern oscilloscope. This is a sine wave that was generated electrically. And you'll notice that the period is 2 divisions. Can you see my cursor?
Yes.
Yeah.
Okay, and that 2 divisions is multiplied by this down here, 500 microseconds. So this period is 500 times 2, which is 1,000 microseconds, which equals a millisecond. The height, we call this the peak to peak. This is twice the amplitude. That's 5 divisions. 5 divisions times 200 millivolts gives us 1,000 millivolts. So this entire height is 1,000 millivolts, or 1 volt, and the amplitude is half of that. This is the, I mentioned this before, but you couldn't see it. This marks the x-axis. Unfortunately, it's not lined up with these dotted lines, but this one here marks the x-axis, and there are 2.5 units either side of that. So the amplitude is 2.5. So again, this corresponds exactly to what you've been studying, but these are electrical signals. These are they're directly related to the mathematics, but they're electrical signals. In fact, this one is, I think, has a period, what do we say, one millisecond. You could hear this if we connected this to a speaker, and maybe in the future we could set that up. There's some online tone generators. But this is all I wanted to show for now, is that these things that you're studying mathematically apply directly. In fact, for years I used function generators, and it never occurred to me that the word function in a function generator means a mathematical function. So that's what I wanted you to say.
Thank you, Mr. Kaplan. All right.
Okay, now I hope I'm not sharing my screen now.
You are not sharing your screen anymore.
Okay,
Thank you.
good.
Maybe we can talk this weekend and see if there's any more that you can share with the class, because I think this is real good for them and good for me too.
Okay.
All right, guys. Let's change gears. Let's go back to exponential functions, and today let's focus on coming up with the equation of an exponential function when given 2 points. And today we'll make them come out nice, and maybe next week we'll do a couple where they don't come out nice. So I'm going to share. Let me get my file together first.
Mr. Sheehan, I'm gonna run. Thanks for letting me check in.
We always love to have you, Mr. Tapia. Thanks for dropping in. I'll see you later.
I'll see you at the meeting. Oh, before I go, Raj just wanted to make sure that I put in a plug for Mr. Souther's. That. All right. I figured.
Yes. Okay.
All right. Bye-bye.
See you later. Thanks. Okay. All right, guys. So let me share my screen with you. It took away open board for me. Okay. Back to this. All right. So first of all, just somebody gives you 2 points on a graph. You could write a linear function that contains the 2 points. There are lots of different kinds of functions. You could write more than one quadratic function that contains the 2 points, most likely. But this says, given that the points belong to an exponential function, write the exponential function that contains the given points. Has anybody done this before? All right. So again, I'm kind of operating under the assumption that you've had some experience with exponential functions. But if you think about what the equations look like that we worked with yesterday, like y equals 1,000 times 1.03 to the x, we're working with the format y equals a times b to the x. And if b is greater than 1, we have what's called exponential growth. This is just in case anybody has not already seen this information. And exponential growth, the graph looks like this. It can never hit the x-axis. No power of a positive number can be anything but positive. A positive number to a power is always a positive number, so that you can't get down to 0. You can get really, really close to 0. The x-axis is a horizontal asymptote for a standard exponential function, but then if you read it left to right, it grows faster and faster and faster. And if the b is positive but smaller than 1, then we've got what's called exponential decay. Kind of like radioactive carbon that we were talking about yesterday. And it's the mirror image of exponential growth. It decays. Exponential growth, something grows faster and faster and faster. Exponential decay, something decreases slower and slower and slower. All right, and again, you'll never hit 0 in theory. All right. So we've got 2 points. We're given that these points belong to an exponential function, so I'm going to write the format y equals a times b to the x power. All right, and I've got 2 sets of coordinates, -2 for x, 200 for y, +1 for x, 982.6 for y. I am going to fit these. I'm going to plug in these coordinates into this formula here. Y equals a times b to the x. Right underneath that, I'm going to plug in these coordinates. 200 equals a times b to the -2. And when you guys studied systems of equations, you added 2 equations together or subtracted 2 equations together. But if 2 equations are valid, the left side of this equals the right side of the top one, the left side of the bottom equals the right side of the bottom, then I should be able to divide the two equations and get a third valid equation. If these two left, so the left side divided by the left side should equal the right side divided by the right side. Okay, so when I do this, 982.6 divided by 200, I get 4.913. And it comes out to a nice decimal, which is why I'm not keeping it as a fraction. If it did not come out to a nice decimal, I'd prefer not. I'll just leave it as a fraction. I'm going to bring down the equals. When I divide the two right sides, the a's cancel out. And what's b to the first divided by b to the negative second? B
cubed.
Right. Don't forget I want to subtract exponents, and 1 minus negative 2 gives me 3. So I get b to the third power. All right. How am I going to solve for b? What should I put into a calculator if I want to solve for b?
Root 3. 3.
Yes, I can tell you're thinking of the right thing, Elizabeth. It's called a third root of 3 or a cube root, a third root of 4.913 or a cube root of 4.913. Here's another way, a cube root. If you know how to access the cube root on your calculator, go ahead and use it. Here's another way of thinking about it. I can use an exponent to cancel an exponent. If I raise both sides to the 1/3 power, I'll get b by itself. Because when I raise a power to a power, I multiply exponents. 3 times 1/3 is 1. So I get b to the first power. If you're doing it this way, though, on your calculator, make sure you put parentheses around the 1/3 and tell me what you get. What's 4.913 to the 1/3 power?
1.7.
Good, 1.7. Again, on your calculator, it's going to look like this. To the 1/3. And that's going to give you 1.7 or 17/10. All right, I've got half of my equation. I've got the b. Now all I need is the a. So now I'm going to move on, and I'm going to pick the top equation or the bottom equation. Doesn't matter which one. And I'm going to plug into that. I'm going to use my 1.7 result and plug into either the top or the bottom and get the value of a. Does anybody have a preference? Should I use the top equation here or the bottom equation?
Bottom.
Okay. Let's do it. Some people would have gone with the top because you've got b to the first power and you won't have to worry about that, but let's not be afraid of anything. Let's go ahead and do the bottom one. Deal with the negative exponent. So I'm plugging into 200 equals a times b to the negative 2, if that's not obvious. And I'm plugging in now the 1.7 for b. And now all I have to do to get a by itself is just divide both sides by 1.7 to the negative 2 power. And can somebody give me that value? And no special brackets required here. You should get a nice answer if you did it correctly.
578.
Good. Your A is 578. And then let's go put it together. Y equals 578 times 1.7 to the x power. That's the exponential growth function that contains those 2 points. Questions?
Yeah, I'm a bit confused.
Okay. What do you think would be more helpful, Victoria? Going back over the steps on this one, or starting another one from scratch and going a little slower?
Starting another one from scratch.
Okay, so let's do that. All right. Let's move on to number 2. And first of all, these points are listed from left to right as I would be reading a graph, because I start with a lower x value and I finish with a higher x value. And I notice y decreases. So I know that's exponential growth, and I'm sorry, exponential decay. So I know b should be 0 point something as a decimal, or a fraction where the denominator is larger than the numerator. All right. So just before I even do any work, I know I should expect this to look like exponential decay. My base should not be bigger than 1. It should be between 0 and 1. All right. So my standard format for exponential function is y equals a times b to the x for a simple exponential function. And if you'd like to avoid working with negative exponents in your first step, then start with the point that has the higher x value, all right, which is x equals 3. Use that point on top. So I'm going to go ahead. So 3 is the x, 1.5 is the y. So I'm going to put 1.5 in for y and 3 for x. And Victoria and anybody else, stop me if I'm losing you. All right, stop me as soon as I'm losing you. All right. Once I've done that, now I'm going to take the other set of coordinates. I'm going to plug -1 for x and 121.5 for y. So 121.5 equals a times b, and now I'm plugging in -1 for x. So you plug in those two sets of coordinates, you put the two equations right on top of each other, line everything up, and then instead of like adding two equations together or subtracting like we do with systems of equations, this is a different kind of linear systems of equations. We're going to divide these two equations. So I'm going to divide left side divided by the left side and right side divided by the right side. All right. And 1.5 divided by 121.5 is going to be probably an uncomfortable looking decimal. And if you have the patience to write all, 9 decimal places, go for it. But if you have a Texas Instruments graphing calculator, if you do 1.5 divided by 121.5 and you hit math, enter, enter, you'll see a much nicer looking answer. This is the same as 1 over 81. Have I lost anybody yet? If you're looking for the math button, it's on the left-hand column. It's 3 buttons under y equals. Do your division, hit math, enter, enter, and it'll give you the fraction version of the decimal that it would have given you. It won't do that if you have an irrational answer. You can't take the square root of 11 and turn it into a fraction because it's irrational and can't be turned into a fraction. All right, now I'm going to divide the two right sides. And a divided by a is just 1, so I can ignore that. B to the 3 divided by b to the -1 is b to the 4th. When I divide powers of the same variable, I subtract exponents. And 3 minus -1 is 4. Now, some of you might just look at this and know what b is. Does anybody know what b is just from looking at it?
One third.
1/3, good. Because some people recognize 81 as 3 to the 4th power. But if not, in fact, if it's not going to come out nice, then you're going to have to do this. You're going to take the 4th root of both sides, or same thing as raising both sides to the 1/4 power. So on your calculator, this is going to look like this. You're going to need both fractions in parentheses. 1/81 to the parentheses 1/4, and it'll tell you, 0.33333. Hit math, enter, and it will give you 1/3. Have I lost anybody on this one?
Yeah, just a little bit.
Okay. So let's backtrack a little bit. So did you follow me here when what I did in this step?
I do have a question about that.
Yeah.
So is the right pair always on top?
Okay, so that's a good question. Let me answer that. But before I do, Mata, were you following this part here, or did I lose you?
Yep.
You were following.
Yes.
Okay. So were you comfortable with how I got the 1/81?
Yeah.
Okay. Were you comfortable with how I got b to the 4th?
Yeah.
Okay.
I'm comfortable with it. I'm just like, I don't know.
Just a lot.
It's just different.
Yeah, it's something new, and there's a lot of steps. Ramon, I'm going to answer your question right now. So it's not necessary to start with the one on the right. If I had done this, if I had put this one on top and this one on the bottom, let me show you what would have happened. I would have gotten 81 instead of the reciprocal of 81. These would have still canceled, but -1 minus 3 would be -4. So then I would have just raised both sides to the -1/4 power, and I still would have gotten the same answer for B.
But it doesn't matter. All right.
It doesn't matter. It's just, do you want to avoid, using the negative exponent?
All right, thank you.
Yeah, these are important questions. So now let's go ahead, and we've got the hard part of our answer, but we've got to get the rest of our answer. We need the y-intercept, or the A. All right, and fast way to do it, if you really see what's going on, if the value at -1 is 121.5, I should just be able to multiply that by 1/3, and I'll get the value at 0. All right, because that's the next value if I'm thinking sequentially. -1, 0, 1, 2, 3. But in general, you always pick one of these equations, the top one or the bottom one, to plug back into. Does anybody have a preference? Which looks easier to work with, this top equation or this bottom one?
The top.
All right, let's plug into the top this time. So now I'm going to come into here. I'm going to, it's not necessary to write it again, but just so I'm being obvious. So I'm using this equation, and I'm plugging in 1/3 for B. And, I can do that out, call that 1/27, and then, multiply both sides by 27, or I can just not think about it and just do 1.5 divided by 1/3 all to the 3rd power. And you do need that 1/3 in parentheses. And you should get 40.5 if you're doing that correctly. Then you combine this information into your final answer. Y equals 40.5 times 1/3 to the x power. There are some examples of this in your textbook too. I'm going to give you a few of these for homework over the weekend. And again, when we got that b is 1/3, we had said up front that we were expecting something smaller than 1 for the b. So it was okay to keep going.
Can we also use this way of solving to solve for equations like normal equation?
Well, Elizabeth, if you ever have a system of 2 equations and 2 variables, and it would help, like you have a situation like this where a variable would cancel if you divided the 2 equations, then yes, it's a valid option.
Okay.
But it does kind of have to be set up something similar to this. You have to have basically two main variables with the same power in each of the equations. So you need an equation with like a to the third and another equation with a to the third, so they'd cancel out when you divide it. And it would have to be a factor of the equation as well. Okay. I can't think of another situation would come up in other than exponential functions, but maybe because just I'm focused on high school math. Mr. Kaplan, can you think of a situation you would want to divide 2 equations other than a situation like this?
I think there are lots of them. I can't think of one. You also have to be careful about not dividing by 0.
Yes.
You need to think about that. But there are lots of cases where they do this. I can't think of one in particular. But maybe if I see one in a textbook, I'll let you know later.
Thank you. Yeah. All right. Let's see. Guys, think you're ready to try one?
Might as well.
Would you prefer one more example, or you want to try and see how it goes?
I'll try one.
All right. Why don't you try number 3? Let's take. Does anybody want to do breakout rooms?
No, sir.
All right. Let's take. Let's do 6 minutes. 9:46. We'll go over it and then we'll call it a day. And by the way, if you, I'm not sure if I gave you any of the ones in the book with fractions. I probably did. The ones with the fractions come out the nicest. They have the nicest answers sometimes. So don't panic if you see fractions. You guys can still see it, right?
Yes.
Okay, thank you. It said sharing is paused, but all right, guys, we're about to go over those. All right. So final answer was y equals 2,500 times 0.8 to the x. If you got that, you can pat yourself on the back and go have a nice weekend. Maybe I'll see some of you guys tomorrow at the Friday session. I posted the homework on Google Classroom while you were doing that. If you'd like, those of you who would like, I'll stay and go through the steps on this. Okay. So.
Have a good day.
You too. Thanks. So we got Y.
Mr. Sheehan, I want to apologize. I had no idea that was visible.
Yeah, well, so yeah, well, if it was anything sensitive, I wouldn't have kept it on there. But so what's going on is my my Zoom. When I first try to share, there's no open board. I can only share desktop and then call up open board.
Okay.
But then I've just discovered today that if I've been in it for a while, if I click new share, then all of a sudden it's there. So I'm going to start to do that on a more regular basis, just so that there's less clutter on the screen for students. And just so if somebody texts you, does give me a private message, everybody won't see it when I call it up.
Well, I kept thinking maybe I shouldn't do this, but I thought it's private, so it won't be a problem. But
hey, if they understood your message, they already know how to do it. And
well, that's a good point.
Yeah.
That's true. There wasn't much information.
Yeah, but I will show them that next week. It's a good idea. All right. So for anybody that's still looking at this, here are your two equations that you divide, and when you divide this, you get 0.512 equals b to the third power. And you might recognize this as 512 1,000ths, and that's 8/10 cubed. It's 8 to the third power over 1,000 to the third power. But if you didn't recognize that, you go ahead and raise both sides to the 1/3 power, and you're going to get b equals 8/10 or 0.8. And then I like this bottom equation to plug into because b is already by itself. Well, b is already to the first power, so when I get rid of the I don't know what I'm trying to say. I don't have to raise b to a power, is what I'm trying to say. So when I plug into 2,000 equals a times b to the first power, it's just 2,000 equals a times 0.8. And I'm going to divide both sides by 0.8 to get my a. Yes.
I actually did it the other way. Like it was 2,000 divided by 1024.
Okay. Do you wanna go over it that way and see what that looks like?
Yeah, because I got it.
Okay, good. So thanks for speaking up. Yeah, we can only help you guys if you speak up when stuff arises. So yeah, so let's see what that would look like. 2,000 equals a times b to the first is on top. 1,024 equals a times b to the fourth is on the bottom. All right, so 2,000 divided by 1,024 gives you, whoops, hold on, 1.953125. If you hit math, enter, it will give you 125 over 64. Did you get that? Or no?
Nope.
What's that?
Decimal.
Okay, so your decimal was 1.953125, right?
Yeah.
Okay, so what kind of a calculator are you using?
Just a normal calculator.
Okay, I believe that calculator has a button. So do 2,000 divided by 1024 again if you haven't already.
Mm-hmm.
And do you see a button that I believe it on that calculator? I believe it looks like something like this, like arrow B over C or something like that. Do you have a button to turn your answer into a fraction?
Yes, I do.
Okay, so when you do that, does it give you 125 over 64?
Mm. Wait, you have to divide it, then press the button, or
Yes. So you have to do 2,000 divided by 1,024, and then I think you can hit enter, and then press that button that, or maybe it even says FRAC or something. But
I got 1.5. Probably that's not the. I just continue. I don't think this is.
Okay, were you going to say something, Mr. Kaplan?
I think I have the same calculator. There's a key that shows F and arrows with a D on it.
Oh yeah, F. Yeah, thank you. Yeah.
Oh, I see.
Fraction to decimal.
Yes, it's right above PRB.
Thank you. That was the next thing I was going to do, is ask you to hold the calculator closer up to the screen.
We can try that. Well, if you need to, I will.
Do you want to try that?
Not working on mine.
Who's that, Josie?
Victoria.
Oh, Victoria. So you have the same kind of calculator as Elizabeth?
Yes.
Okay. So there is a button that says F arrow D, or no?
Yes, I see it.
Okay. So what you want to try, because this is worth spending a little time if you know how to do this on your calculator. If you try typing in 2,000 divided by 1024, and then hit this button.
Wait. Let me interrupt. What it gives is, it gives 1 and 61/64.
Okay.
Yeah.
Okay. All right. So I guess it gives you 1 and 61/64. So then I guess it's up to you to do 1 times 64 plus 61.
But then there's another button that'll convert that.
Oh, there is? So what do you press?
Yeah. The next one down does that. Let me see if I can.
Okay.
Can you see this?
A little bit.
Well,
it's a little bit.
Well, the one above the PRB does the first conversion, and then the one the one below that with the shift key does the second conversion that you need.
Oh, with the shift key? Okay.
Yeah, you need the shift key for each one.
Oh, for both of them. Okay.
Well, I mean the second key, I guess is the
second. All right.
Yeah. Let me see if I can find a way to do this in one step.
Oh, I see. It works. Thank you.
Okay. How about you, Elizabeth? Are you getting it?
Yeah.
Are you still working at it, Elizabeth, or are you?
Yeah, I got the.
You got the 1 and 61/64.
Yes.
Okay. Mr. Kaplan, are you able to draw on the screen and tell her what the other button looks like that she should press?
Why don't we try this
Okay.
If she just does second and then presses the one just below the one she already used, try that, and then I'll try to draw on the screen.
So if you have the 1 and 61/64, press second, and then press the button below the one you just used.
Okay.
Try that out.
Oh yeah, it works.
It works? Good. Beautiful. Thank you, Mr. Kaplan. Yeah, that's a good calculator you have, and yeah, it's worth spending some time so you know how to use all its good features.
Thank you.
Yeah, so now if we've gotten that far, so that was probably part of the issue, but now you've got 1 minus 4 on the right side, so that's -3. And all right, so now we're gonna, to cancel out the -3 exponent, we're gonna use the reciprocal exponent, which is -1/3. All right, and you should be able to. Your calculator has parentheses. I'm pretty confident. So parentheses 125 divided by 64. Hit your exponent button, which I think is it looks like a to the b, right? Parentheses -1 divided by 3, and it should give you 1.25, which you can convert into hold on a second. No, I'm sorry. It should give you 0.8. I was thinking of the positive 1/3, which you can convert into 4/5. How about this one? Are you able to get this?
Yes.
Okay. How about you, Elizabeth? You able to turn that into 4/5? Yes? Okay, good. So your uncle's on the computer now, right? You're slowing down a little bit, right? Okay, so now, so that's the hardest part of this. Now you've got 4/5, or you can use 0.8. You really don't need to keep a fraction, you know. So I did it, over here, what it looks like as a decimal. If you want to do it as a fraction, then it would look like this: 2,000 equals a times 4/5, and then you just multiply both sides by the reciprocal, times 5/4 times 5/4, and then you'll get your 2,500 equals a.
I got some questions.
Yeah.
The first one is the first part we did in class of converting from the equation to.
Sure. I'll be happy to go back to those. Elizabeth, are you comfortable with this one now? Are you okay on these?
Yes, I am.
Okay. All right. So, Victoria, would you like to just do a random one from scratch, or go back to a specific one?
Do a random one from
Okay,
scratch.
let's do a random one from scratch. All right. Keep recording this. Let me shut this.